Hello guys, how are you? I hope you're doing well. Okay, we're going to continue with the next rules. The next rules that we're going to work with are the rules for trigonometric functions. As we have 6 different trigonometric functions, we have 6 different rules for finding the derivative of trigonometric functions. So these are the 6 rules that we're going to use for finding the derivative of each of them. Okay. The rule of sine is the derivative of u times cosine of u. The rule of cosine is negative u prime times sine of u. The rule of tangent is u prime times secant squared of u. The rule of cotangent is minus u prime times cosecant squared of u. The rule of secant of u is u prime times secant times tangent of u. And the rule of cosecant of u is minus u prime times cosecant of u times cotangent of u. Remember that you don't have to memorize these rules. They are given in the set of formulas that we're going to give you in the exam. So you don't have to memorize them, okay? Who is u in all rules of trigonometric functions? U is always, so u is always the angle of the trigonometric function. Remember that trigonometric functions refer to an angle always. Sine of an angle, cosine of an angle. For example, when you were working in 4th semester with trigonometry, sine of 90 degrees, okay, or cosine of pi, okay? So we always refer to an angle. U is always the angle of the trigonometric function. It means that you cannot just write sine without any angle joining the phrase of sine. Sine of u is a single piece that you cannot split. Keep in mind that, okay, when working with trigonometric functions and derivatives of trigonometric functions. So u in all the rules for derivatives of trigonometric functions is always the angle, okay? As you can see in the rules of derivatives, the signs are interchanged, starting with sine, cosine, tangent, cotangent, secant, cosecant. The signs are interchanged. We have plus, minus, plus, minus, plus, minus, okay? Look at the signs of the derivatives. And as you can see in the derivatives, we always start, well, after the sign, obviously, we always start with the derivative of the angle, okay? Don't forget that you always have to start with the derivative of the angle. So like in the other rules we've been working with, once that you identify the rule you have to use, you always have to take the derivative of u because you need it in the formula, okay? So you identify the formula, you identify who is u according to the formula, and then you take the derivative of u because you need them, you need u prime in the formula, okay? These are the last rules we're going to work with after working with the trigonometric functions rules. We are done with all the rules. Okay, so before starting with the examples, I want to remind you something. These are the trigonometric identities that you have learned in 4th semester, okay? You have to recall them because there are some problems where you need to use trigonometric identities to rewrite the problem before starting with the derivative process, okay? So the ones that you have to remember, because you work with a lot of identities, but the ones that you have to remember are reciprocal identities, quotient identities, and Pythagorean identities, okay? Reciprocal identities, as the name says, these are the ones that refer to the reciprocal of the given trigonometric function. So sine of x is 1 over cosecant, because cosecant is the reciprocal of sine. Cosine of x is 1 over secant, because secant is the reciprocal of cosine. Tangent of x is equal to 1 over cotangent of x, because cotangent is the reciprocal of tangent, and the other way around. Cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. Okay? Quotient identities, we have tangent and cotangent. Tangent of x is sine over cosine of x, and cotangent is the reciprocal, cosine over sine. Since tangent and cotangent are reciprocal identities, okay? And finally, we have the Pythagorean identities. Sine squared plus cosine squared of x equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared, okay? We have these 3 Pythagorean identities that you were using in 4th semester. We have these 6 reciprocal identities, and we have 2 quotient identities. So it's important that you remember them, because there will be some problems where you will have to use the fundamental trigonometric identities to simplify the given problem and rewrite it to make it easier when finding the derivative, okay? Okay, so let's start with some examples. How are you going to know that you have to use the rule of a trigonometric function? Well, obviously, because the given problem is a trigonometric function, okay? This is how you're going to know. Like in all the rules we've been working with, there will be some problems where you have to start with the product rule or the quotient rule, okay? How are you going to know that you have to start with the product rule or with the quotient rule? Because the given problem is a product of 2 functions of any type, or because the problem is a quotient of 2 functions of any type, okay? So we can have problems where we have a polynomial times a trigonometric function, and the main rule that you have to use there is the product rule, and inside the product rule you will have to use power rule and a trigonometric function rule, okay? So exactly the same as the previous rules we've been working with, okay? Everything will be mixed now. Also, the angle of a trigonometric function could be an exponential function, okay? So we will have mixed rules there, exponential rule with trigonometric rule, okay? So everything could be mixed now, okay? All the rules. Okay, so the instruction is the same as always, find the derivative of the function. As you can see here, we have a sine function. So we have to use the rule of the sine function, okay? I'm going to write it here. The derivative of sine is u prime cosine of u, okay? That's the derivative of sine. If you want to go back to the formulas, you have them here. Okay, the derivative of sine is u prime times cosine of u. Okay? Okay. So, who is u in the trigonometric functions? As I told you, u is the angle always. Okay? This is the angle of sine. This is u then. So, u is 3x minus 2. U prime is 3 with the power rule, obviously. Okay, and you just have to follow the formula of the sine function to find the derivative. Okay, so, well, what about this constant that we have here at the beginning? As always, with all the other rules we've been working with, you just paste it to the derivative. Okay, so this is what we're going to do. 2 times the derivative of sine, and the derivative of sine is u prime cosine of u, so it is going to be 3 times cosine of 3x minus 2. As always, you multiply the monomials, okay? Two times 3, which is 6. And there is nothing else you can do. Please don't do weird things, okay? Don't make algebraic mistakes. A very common mistake in exams is trying to multiply constants times the angle, okay? Doing things like cosine of 18x minus 12. You cannot do distributive property with the angle and a constant outside the trigonometric function, okay? This is completely wrong. Be careful with that. The angle, as I told you, is a single piece with the trigonometric function. I mean, this is a single piece that you cannot split. Okay, so be careful with the algebraic mistakes. Okay, so that's the answer. There is nothing else we can do. We're done with it. Okay. Number 2. The instruction is the same. Find the derivative of the function f of x equals 7 sine of x cotangent of x. Okay. Now, since we have 2 trigonometric functions multiplying, you may think in using the product rule, where u is 7 sine and v is cotangent. But that will be very long. Okay? So, always when working with problems of derivatives of trigonometric functions, try to use the trigonometric identities that you learn in 4th semester to reduce the expression if possible, okay? Here, for example, we can use the identity, the quotient identity of cotangent equals cosine over sine. Do you remember? I'm going to write it here. Cotangent of x is equal to cosine of x sine of x. This is the quotient identity of 4th semester. Okay, so we can rewrite the problem by making cotangent equal to cosine of x divided by sine of x. What happens with sine? Sine will be canceled, and this will be 7 cosine of x. Okay, so the function I'm going to differentiate is just 7 cosine of x. This is pretty much easier to differentiate than doing the product rule with the original expression. Can you see that it is easier to just get the derivative of 7 cosine than obviously using the corresponding rule of cosine than doing the product rule for sine and cotangent. Okay, so as I told you, always try to use trigonometric identities if possible to make a shorter expression of the given problem. Okay, so here, since it is 7 cosine of x, well, 7 is just a constant that you're going to paste to the derivative of cosine. We are going to use then the formula of cosine of u. The derivative of cosine is minus u prime sine of u. okay? Minus u prime times sine of u. So who is u? Don't forget that u is always the angle. This is u, okay? So u is x, u prime is 1, and we just have to follow the formula. Minus 1 times sine of x. Okay, so this is minus u prime sine of u. There is nothing else we can do. You can also write it as minus sine of x. It's not necessary to write minus 1. It's the same, okay? If you want to write it, do it. It's the same, but it's not necessary. Okay, so exactly the same as we did in the previous example. U prime cosine of u, okay, is the same that we have to do here. U minus u prime sine of u. Just follow the formula. Number 3. Find the derivative of the function f of x equals tangent of 3x squared minus 5x. Okay. So how am I going to know that I have to use the trigonometric rule? Well, because tangent is a trigonometric function. So you will have to use it, okay? What is the rule of tangent? Tangent, the derivative of tangent is u prime secant squared of u. Let me write it. Remember that u is always the angle of the given trigonometric function. So the rule that we're going to use is the rule of tangent of an angle, which is u prime secant squared of u. Okay. Secant squared of u, just for you to know or remember, is equivalent to have everything raised to the second power. Okay. Secant squared of u is not the same as secant of u squared. Be careful with that. Okay. When we have here the power beside the angle, it's applied to the angle. But when we have it beside the name of the trigonometric function, it means that it is for the whole trigonometric function, including the angle. Okay, be careful with that. Okay, so u is 3x squared minus 5x. U prime is 6x minus 5. Just follow the formula. U prime, use parentheses, please. Use grouping symbols. Times secant squared of u. So secant squared of 3x squared minus 5x. Okay. Remember, this is a single piece that you cannot split. Be careful with that. So according to the formula, this is u prime and this is secant squared of u. Okay, which is a single piece. There is nothing else we can do. So that's the answer. Okay, this is the answer. Don't do distributive property because as the previous rules we've been working with, you must give your answer in simplest form, completely simplified and completely factorized. Okay, so if you do distributive property, you undo the factorization. So don't do distributive property. Okay. Okay, number 4. Well, number 4 and 5 is a comparison of two problems that seem very similar, and that you may think that you have to solve them using the same procedure, okay? This has to do with what I mentioned a moment ago, that depending on the location of the exponent is to whom it is applied. If the exponent is beside the angle, the exponent is for the angle, okay? If the exponent is beside the name of the trigonometric function, it belongs to the whole trigonometric function. So the order in which we are going to apply the rules is different for each of them. In example 4, the exponent is applied only to the angle since it is beside the angle, as you can see here. Okay, it's just for the angle. So it means that I'm going to start with cosine rule, since we have a trigonometric function which is cosine. And the second thing that you're going to do is apply chain rule inside cosine rule. Okay. This is the order in the order on how we are going to apply the rules. On the other hand, in example 5, we have cosine squared of an angle. So it means that this expression is equivalent to this. Everything raised to the second power. Okay? So it means that the order of the rules is going to be start with chain rule, and apply cosine rule inside chain rule. Okay? So as you can see, the order is different. Okay, so be careful with that. Okay, we're going to start then with example 4. Well, the rule that we're going to use, as I told you, we're going to start with cosine rule. F of x equals cosine of u. The derivative is u prime sine of u. Okay? Who is u? The angle, the whole angle, including the power, because that power is affecting the angle, as I told you. And you're going to use the chain rule to get the derivative of u. So this is going to be 2 times 8x squared minus 1 times the derivative of u. So, I mean, the derivative of what you have raised to the second power. I'm following the chain rule that you already know. So this is 32x 8x squared minus 1. Okay? And you just follow the cosine rule, which is, I made a mistake here with the sign. Just let me make the correction. This is minus u prime sine of. So minus u prime sine of u. Okay. And there is nothing else I can do. Okay, just to show you, this is minus u prime, and this is sine of u. I'm just following the rule, okay? And that's all. Don't do distributive property because you don't do the factorization. Remember, you must give answers in factor form as always, okay? That's it. What about the other problem? We have to start with the chain rule, and inside the chain rule, we're going to apply the cosine rule, okay? So for the chain rule, u is going to be, let me write the chain rule. N times u to the n minus 1 times u prime, okay? So u is the whole cosine because that's the expression that is raised to a power, okay? So this is going to be cosine of 8x squared minus 1. And inside the chain rule, I will have to use the cosine rule. The cosine rule is, as we saw in example 4, just a moment ago, minus u prime sine of u. So the derivative of cosine is going to be negative 16x sine of 8x squared minus 1. Okay, so this is minus u prime sine of u. I'm just applying this rule, okay? So going back to the chain rule, which is my main rule here, following the chain rule is going to be 2n times u to the n minus 1 times the derivative of cosine. Use parentheses, please. I'm going to use brackets. You can use any grouping symbol, okay? But I like to use brackets. Okay? Arrange the expression. Remember that you have to multiply monomials as always, okay? So arrange it. Multiplying monomials, you can multiply 2 times negative 16x. Okay, so this is going to be minus 32x sine of, I'm just arranging, okay? But it could be cosine before sine is the same. Okay, minus 32x sine of 8x squared minus 1 times cosine of 8x squared minus 1. Okay, There is nothing else we can do. Remember, do not isolate the angle from the trigonometric function and try to do operations with it. That's it. There is nothing else we can do. Okay. Okay. Number 6. Okay, find the derivative of the function. Now notice that this is a different example. As you can see, we have a product of two functions. This is one function, and this is another function. Since we have two functions multiplying, we have to use the power rule, the product rule, sorry. Product rule. That's my main rule. Okay? U v prime plus u prime v. Okay? Who is going to be u? 12x squared. So u prime is 24x, and v is secant. Okay? How are we going to take the derivative of secant? Well, it's a trigonometric function, so we have to use the corresponding trigonometric rule. Okay? So the main rule here is the product rule, and inside the product rule, I will have to use the power rule for u and the secant rule for v. When we have the secant of an angle, the derivative is u prime secant times tangent, okay? U prime secant of u tangent of u, okay? Okay, so let's see. Okay. Follow the rule, okay? Remember that u prime is the derivative of the angle. So the derivative of the angle is 6 secant times tangent, okay? So this is going to be 6 secant of 6x times tangent of 6x. So this is u prime. This is secant of u, and this is tangent of u. Okay? I'm just following the formula. Now you're ready to apply the product rule. Okay, so following the product rule, u v prime plus u prime v. Okay, this is going to be 12x squared times 6 secant of 6x tangent of 6x. Okay, plus 24x times secant of 6x. Okay, I'm going to multiply monomials. I'm going to arrange, and then I'm going to take out the common factor. Okay, so this is going to be 72x squared. Remember, I'm multiplying monomials. Okay, 72x squared, secant of 6x, tangent of 6x plus 24x, secant of 6x. Take out the greatest common factor as always and simplify. The greatest common factor here is 24x secant of 6x, and the remaining expression is going to be 3x tangent of 6x plus 1. Be careful when factoring, okay? It's plus 1, not plus 0, because since we have the same expression, I mean, here and here, since they are equal, the remaining term is 1, not 0. Okay, be careful with that. Okay. So remember, we're just following the product rule. Okay. Let me write it here just for you to remember. U v prime plus u prime v. There is nothing else we can do after factoring. So we are done. Okay. One more example. Tomorrow we're going to continue with more examples, because since we have 6 different trigonometric rules for the 6 trigonometric functions, there are a lot of combination of problems that we can have with trigonometric functions. So this is just part 1. Tomorrow we're going to continue with part 2. Okay, one more example for this first part. The instruction is the same. Now, as I told you, always try to use trigonometric identities if possible. Here you can use obviously the quotient rule, or you can bring sign to the top, but this should be raised to the negative power, everything, -1 power, and then you will have to do a chain rule and so on, or use trigonometric identities. Okay, you can use the reciprocal identity. What is the reciprocal identity? The reciprocal identity is cosecant of x equals 1 over sine of x. Okay, if we rewrite this expression, as you can see, we have 1 over sine. Okay, so this is going to be using the trigonometric reciprocal identity. This is going to be -5 cosecant of 10x squared. Okay, and it is easier to use the cosecant rule, the corresponding cosecant rule, than to do the the chain rule, or do the quotient rule, which is larger or a little bit more difficult than just doing directly the cosecant rule. Okay, so once that you have rewritten the problem, I'm going to write it here at the bottom. -5 cosecant of 10x squared. Remember, we are rewriting this expression or replacing 1 over sign with the corresponding reciprocal identity, okay? So once that you use identities, now you can start with the procedure of derivative. The derivative of cosecant of u is negative u prime cosecant of u cotangent of u. Remember that u in trigonometric functions is always the angle. What is going to happen with this constant? Just paste it to the derivative as always. Okay, so u prime, u is 10x squared, u prime is 20x. Follow the rule. Okay, just follow the rule for the derivative. This is going to be well, just paste the constant, don't forget. Paste the constant, -5 times negative 20x times cosecant of 10x squared times cotangent of 10x squared. Remember, I'm just following the rule. This is minus u prime cosecant of u cotangent of u. Okay. What's next? Multiply monomials as always. If possible. So the final answer is going to be 100 of x cosecant of 10x squared cotangent of 10x squared. And there is nothing else you can do. You are done. Okay. Okay, guys. So this is the first part for examples about derivatives of trigonometric functions. As I told you, we're going to continue tomorrow with the second part with more examples about derivatives of trigonometric functions. And also we're going to do some examples where you have to find the equation of the tangent line, but using these new rules, okay? Similar problems to the ones we're going to have in web assignment. Okay, so see you tomorrow, guys. Bye-bye.